In this video, we are going to see the turn on methods of SCR, otherwise called SCR triggering methods. So first of all, we should know what is triggering. It is a process to turn off the SCR. So here, when we have the thyristor or SCR is forward bias, that means anode is connected to the positive supply and a cathode is connected to the negative supply. So at that time, junction J1, J2 and J3 are forward biased and the J2 is reverse biased. So due to that, there is no current flow through the device. So we need to make this junction J2 as break. So in order to break that, we have different methods that is called triggering of SCR. So here different methods of SCR is, so these are the 7 different methods, basic different methods of a turn on methods of SCR, otherwise called triggering method of SCR, otherwise called firing method of SCR. So in order to understand those methods, we must understand the equation called anode current equation. Anode current equation of the SCR as like this. It is this equation is derived from two transistor analogy of SCR. So here it can be noted in the denominator we must have that we have the term called 1 minus alpha 1 plus alpha 2. Alpha, it is, since it is a two transistor analogy, alpha is called the current gain of the first transistor, current gain of the first transistor, and alpha is the current gain of the second transistor. So we must make, by somehow we must make this alpha 1 plus alpha 2 as 1. That means the denominator we have the term called 1 minus 1, that becomes 0. So anything divided by, in the denominator we have the result as 0. So that time we have the infinite amount of current is flowing. There is a infinite amount of current is flowing. So that means the ultimate aim is to make this current gain as a high value, that is close to high value. That time we have the anode current as very high. So in order to have this anode current or alpha 1 plus alpha 2 as a high value, many methods are there. We will see one by one. So here the first method is called a forward voltage triggering. It is a very fundamental methods, just increasing the forward anode to cathode voltage by using some arrangement. When we keep on increasing this applied voltage, after some time, after some voltage, the junction J2 getting breakdown. So this method is called a forward breakover method. So this is not employed because we need to have larger amount of anode to cathode voltage. So this is not advisable for practical applications. And the second method is called the temperature triggering method. So here we have from the transistor technology, the reverse leakage current. From the anode semiconductor technology, the reverse leakage current is fully dependent on temperature. When the temperature is increases to some value, that means the current is also increasing, and the whole pairs are also increases. Due to that, there is a larger amount of current, there is a larger amount of leakage current, which will increase the current gain alpha, So when the current gain of alpha, if you see this equation, when this current gain of alpha is increased by increasing the temperature value, so that when this alpha 1 and alpha 2 value are approaches close to unity, that means this denominator value has very less value. When the denominator value is very less value, this IA values increases, thereby the anode current is very high. So again, this is also practically not dealt because it causes the thermal runaway problem. We should have some limitation by increasing the temperature, so that will lead the problem called a thermal runaway problem. So due to that, the SCR may be damaged. So this is not advisable method. That is called temperature triggering method. And the third method is called third method, dV by dt method. So again, if you have the SCR is forward biased, junction J1 and J2 is forward biased, and J2 is a reversed bias. This J2 junction will be acting as a capacitor, that is so when with the current through the capacitor, we have the equation I is equal to dV by dt. When we keep on slowly, this rate of change of voltage is larger when we keep on increasing the rate of change of voltage beyond particular value, which will lead the current which will lead the charging current is enough to increase the current value alpha. That time we have the current gain value alpha is getting increased, so thereby anode current is also increases. So here this is since this voltage rate of change of voltage is very high, the high voltage spikes across the device, that will damage the device. Since we are varying the voltage, increasing dV by dt is continuously, that will damage the SCR. This is called the third method, dV by dt triggering. And the fourth method is called a light triggering. So here this light radiation, this is also called light activated SCR. So here a light ray with the appropriate wavelength is allowed to strike at junction J2. So this junction J2 is getting breakdown, so thereby the current is flowing through the SCR. Right. So there will be a small light, there is a small hole in the inner P layer. When the light is strike on this hole, this small hole, there is a electron hole pairs are generated across the junction J2, which will increase the current to turn on the SCR. And this is also same thing. There is a inner P layer. We have the small hole, small lights. There we have the light, high intensity of light is passes through that, so through which the SCR is getting on. And this is the conventional method, most reliable method, simple and efficient method called DC gate triggering method. So by somehow in the gate terminal we need to have some extra circuit. This circuit is called a gate circuit, through which by varying this voltage, gate supply voltage, this gate current is also getting increases. So here a positive gate voltage between the gate and the cathode is applied, so through which there is a gate current is established. This gate current will allow to break the junction J2. Now here by increasing the supply voltage, by increasing the gate supply voltage, thereby the current gate current is also increases slowly. For different values of gate current, it is noted Ig1 is the first for particular voltage. For let us say V1 voltage, for particular voltage there will be a I1 gate current. For V2 voltage there will be a Ig2 second gate current, and Vg3 is a third gate current. So here V1 is a higher value, so that time the gate current is somewhat high. We need to have some value, Ig1. So coming to here, so this is called a forward breakover voltage. When we have the higher gate, when we have the lesser current, that time we have the higher forward breakover voltage. Again Ig2 is a somewhat higher gate current, again that time we have lesser forward breakover voltage, that we can call it as Y. When the gate current is very high, Ig3 is very high, so the SCR may get turned on very quickly, that is called a forward breakover voltage is less. Since we have the gate current is high, the SCR is getting turned on very quickly. So this is called a gate triggering method. So here we can conclude that when the gate current is increases, the SCR may get turned on very quickly. So this is a very reliable and economic method. All the converter circuit, inverter circuit are working, converter circuit are working with this DC gate triggering method. And next method is called AC triggering method. It is mostly commonly used in AC applications. By using some isolation transformer, the main circuit and the trigger circuit is getting it. This is called a main circuit. On the left side we have the trigger circuit. So those circuits are getting isolated using pulse transformer. So using some AC power supply circuit, this ACR can be triggered from the main supply. So this we will see this supply we will use many places called a single phase rectifier circuit. We will see this circuit very easily. And the last method is called a pulse triggering method. So in this method, a single pulse or a train of pulses is applied to the suppose we have the SCR like this. We have the gate terminal. So in that gate terminal we must have some single gate pulse or a train of pulses like this. We are applying. So this method is called pulse triggering method. So it is called a gate drive is a discontinuous or does it need any. So once this gate pulse is given to the this pulse is given to the gate, this SCR is getting turned on. Thereafter there is no meaning in the meaning by giving there is no meaning of giving a gate pulse to the SCR. So the SCR is getting continuously conduction. So there is no need to give the gate pulse. That is the last statement. So in this way we can make the SCR as a SCR triggering different triggering circuit. So thank you.